Hello, I'm going to talk about how to use a haemocytometer. So a haemocytometer is used whenever you want to count the number of cells or estimate the density of cells, the number per cubic millimeter usually. It's used for any cell that is large enough to see with a light microscope. It is used to count, for example, red blood cells or white blood cells. It is really useful to count a yeast population. So you can grow a yeast population in a conical flask with a glucose solution, and then you can transfer that onto the haemocytometer and you can estimate the density or the number of yeast cells in a cubic millimetre. So the structure of a haemocytometer, so this is a haemocytometer slide that has been set up. So here you have the glass slide, it's quite thick, and in the middle of it you have an H, and that H, those are deep grooves. And then over that you put a cover slip whenever you're doing your count. But in this region here and in this region, when you look under the microscope, you will see grids, which are counting grids. Now, there are three types of square on those counting grids. The biggest square has an area of 1 square millimetre. Now, whenever the cover slip is put on top of the haemocytometer, the distance here, you see the hash distance here, in my example, is we know that it's 0.1 millimetre in height. So if the area of a square on the counting grid is 1 square millimetre, the volume of solution that would be on that square, remember that the volume is the length times the breadth, which is the area, times the height, would be 1 times the height, which is 0.1 millimetre. So the volume that will fit in an A square is 0.1 cubic millimetre. So a B-type square is smaller and its area in my example is 0.04. So the volume of a B-type square will be the area multiplied by the height. So 0.04 times 0.1, and this is what it comes out as. And then the smallest square is a type C square, and it has an area of 0.0025. So to work out its volume, it's 0.0025 times 0.1, and that comes out at 0.00025. So that is the haemocytometer. So what is the method? So what you do is you place some of the suspension on a counting platform and you put on the cover slip. Now if any of that solution leaks into the grooves, you need to start again. So you just clean it, dry it, and then you start again. So you put some of the suspension on the counting platform, and then you look at the cells underneath the light microscope and you decide which type of square is best to count. If the cells are very, very dense, you'll need to use a type C square. If there are very, very few yeast cells when you're looking down the microscope, you might have to use an A square. So you need to look down and see what they look like, and that helps you to decide what square you're going to use. Whenever you're actually counting the cells, you use the northwest rule. And that rule is you count the cells that are absolutely for sure in the square, or you also add to that the cells that are on the north of the square that are touching the line at the top of the square or to the left of the square. So that's the northwest rule. If you're asked about why you use that rule, that makes sure that cells are not counted twice. So you'd count a lot of maybe type C squares, and then to work out the density, so that is the number of cells per cubic millimetre, it's really easy. It's the average number of cells in that type of square. So that might be the average number of cells in a C-type square. You've counted 20 C-type squares and then you find the average and you divide that by the volume of that square. And earlier we've talked about how to measure volume. Now, in these questions, you'll very often be asked about precautions that you should take when using the haemocytometer. Well, first of all, you need to make sure that the haemocytometer grid is not it is full. Sometimes it might be just half full. So you need to make sure that it is full but not over full. So if any of the solution gets into the grid, that would suggest it is overfull. So you have to start again. So that's the first precaution. And then if you're placing like yeast cells onto the haemocytometer grids, before you take them out of the conical flask, make sure that that has been mixed thoroughly so that the cells haven't time to settle at the bottom of the conical flask. So after you have mixed your flask thoroughly and you're taking a little sample with a dropper, always sample from the same depth in the flask, maybe from the middle of the flask. And then if you're sampling water, which has, maybe you're looking at phytoplankton, which it has been taken from a lake or whatever, whenever you're taking the sample from the lake that you're going to use for the haemocytometer, just making sure that you sample at the same time every day in case that would affect where you find the phytoplankton. So when using a haemocytometer, you wouldn't just count the population once, you would repeat many, many times for reliability. And whenever you're choosing your type A, B, or C squares, the ones that you're actually going to use to count, select them randomly, and that prevents bias. Now, there are some drawbacks when looking at yeast cells because living and dead yeast cells look exactly the same. And so you think you've got this massive population, but half of them could be dead. And that's really difficult when you're trying to estimate the number of cells in the stationary phase and in the decline phase. So just be aware of that. There isn't a lot you can do about that, but that might be why you have an overestimation of cells which you think are in the decline phase. So what happens if you look down the microscope and you've got a type C square and you've still too many cells? So what you do is you dilute the suspension by a known factor, a dilution factor. So for example, your conical flask, you would dilute it by a factor of 10. So how would you do that? You would use it, give it a good stir, and then using a pipette, transfer 1 cubic centimetre of that suspension into, it could be into a boiling tube. And then you would add 9 cubic centimetres of an isotonic buffer to that boiling tube. You need to add an isotonic buffer. It needs to be isotonic so that the cells don't take in water by osmosis and burst, and it needs to be buffered so that there is no enzyme damage. So then using this diluted solution, you then count the cells. And whenever you've got your final results, you multiply your result by the dilution factor. So in this case, it was diluted by 10. So then, say we get 5 cells in every C square, we would then multiply that by 10. So we would say that the density was 50 cells in 1 cubic millimetre. I just want to mention this. There is another way to measure a growing bacterial or yeast population. You cannot, sometimes you can't see individual bacteria with a light microscope. Sometimes you can, sometimes you can't. So you've got this conical flask and bacteria are growing in it. As time goes on, as the bacterial population grows, the flask will become cloudier and cloudier. So you can actually estimate the size of the bacterial population by measuring the cloudiness of a solution. So the cloudier it is, the greater the size of the bacterial population. And you can measure the cloudiness of the solution by using a colorimeter. Now, once again, can you find some past paper questions on this and see if you can do them?